Here I'd like to look at a very famous paper, very interesting paper by a philosopher named John Searle. It's Minds, Brains, and Programs, 1980. So it's a pretty old paper, but it's one of those old papers. It's a classic. Philosophers, some of them love it and think it proves and shows and ends ends a debate. Others say no, it's nonsense, and still others like me I think it's a really interesting and thought-provoking paper, and I think Searle's presents a very formidable view that is still arguably something we're working with. I think there's a little bit of channeling of Alan Turing in this paper. He doesn't really go into Turing's work, but I think he's picking up on a Turing thread that is articulated in the solipsism discussion of Alan Turing in his 1950 article, Computing Machinery and Intelligence. But I'll get to that in a minute. In any case, what's really going on here? There's a lot of fuss about this paper, and I think it's fairly straightforward in a sense. And all I want to do in a couple of videos is just give you an idea pretty well of what's going on in this, and with some simplifications, admittedly, but I think I'm hitting clearly what Searle is after and what he's not after. So you want to be clear about both of them. Like, what he's not saying is important too, because it's easy to overread what he's doing here. So let's start just by trying to get an overview of this paper, the big picture. Now it goes something like this. There's a couple of points he wants to make, and he thinks if he can drive those home, he's accomplished his task. The first point he thinks is, and remember, he doesn't think this is really controversial, is that causal and physical features of the brain. So he's talking about our brains, human brains, causal features. So everything is within the realm of the physical. The entire discussion is the realm of the physical. So don't ever think that Searle is postulating or thinking of any abstract things or whatever. No. Brains, our brains, right? Flesh and blood stuff. The causal features, the physical features of the brain produce intentional states. This term intentional or intentionality, it's a minefield. There's millions of different ways to discuss it. It's an important concept in philosophy. Roughly, something very simple. To have an intentional brain state, it means you're conscious, you're thinking about something. It's a consciousness of something. We do this all the time, right? What are you thinking about, right? And you're reflecting on something. Question is can computers do that, right? Can they think about something? Can they have that directedness of thought, that intentionality, directedness towards something that we have? Now, you might say we don't have that, and some schools of thought have tried to get away and say that's just a kind of illusion. That's off the rails of the discussion here. We are saying that humans have intentionality, our brains produce it, it's physical, it's a byproduct of a physical mechanism, right? The question that Searle wants to ask and then answer, don't they say philosophers just ask questions and don't answer them? They do. They ask the important questions and they try to just, other philosophers often don't agree with the answers. But what Searle says is that, yeah, the brain produces intentional states. There's meaning, interpretation, right? So when I say, what are you thinking about? You can tell me what it's about. It means something to you. It's hard to dig underneath and say, well, what is the meaning of meaning? Although people have tried. But basically, you're thinking about, like, if I give you, well, think about this. All these little squiggles on the board here. Right? You understand the meaning of these. You're not actually, like, think about this. Think about that. If you didn't understand anything about English, or if you could, think if you couldn't read or anything like that, that would just be a squiggly pattern, right? It wouldn't have any meaning. So when you're looking at all these squiggly patterns here, you would say, well, they're not just squiggly patterns, they're words. But you're not actually looking even at the word, you're looking at the meaning behind it. So you have these intentional states that are full of meaning, right? It's not like this thing here, the brain that word, that little squiggly pattern is indistinguishable from that, right? You look at that and go, I don't know what that means, right? So this is a full-blown intentional state that you have of that. It's full of meaning. This one, maybe not so much. That distinction is crucial for what Searle's up to here. So our brains produce these intentional states. It's all physical, nothing weird or mystical going on, where these states are meaning, they have meaning and interpretation. His point, what he wants to drive home now, is that computers can't do that. Now, what does he mean more precisely? A computer program cannot do that, right? It can't produce intentional states. In other words, computer programs in your computer don't produce those kinds of states in your computer. Those kinds of states are all physical, but they're produced here by the structure, the physical structure of the brain. So your computer doesn't have the right kind of physical structure to produce these. That's all he's saying, right? Is that hugely controversial? Well, some people think it is. What he's not saying is that per se, in writ large, oh, computers can't think, machines can't think. He's not saying that. He is saying kind of, well, we're machines. We're a special biological kind of machine, and we think. So can machines think? Of course. And as a matter of fact, only machines can think. Why? Because everything that thinks has to have the right kind of causal architecture, and that is basically the causal architecture that can, like a table doesn't have the right kind of causal architecture, a computer doesn't have the right kind of physical causal architecture, a brain does. Maybe other kinds of causal architectures that we can dream up, other kinds of machines, sure, right? A simple machine like a lever, right? No, that doesn't have the causal architecture that could produce intentional states. But you can't produce intentional states unless you have a causal architecture underneath it. So if we look at this now, that the physical features, okay, produce of the brain, produce the intentional states, computer programs can't do it. How? This one seems pretty obvious. Number one seems, yeah, well, unless you want to deny that we do it, but let's say we have brains that produce intentional states. How would you show that a computer cannot produce an intentional state? That's what he's trying to do. That's his little thought experiment that's been informally referred to as the Chinese room experiment. It doesn't matter if it's about the language question. Any language will do, and I'll talk about how that works. Searle uses the Chinese language because he doesn't know Chinese at all. But if you know Chinese, then it won't work. You'll have to pick a language you do not know at all. All right, but we'll get to that in due time. So he wants to show that a computer program cannot produce intentional states. How is he going to do that? He's going to show it by having a human instantiate a computer, so be the computer, and not have intentional states. So how do you get a human to be a computer? Well, that's the little thought experiment that he's going to, in a sense, he's riffing on Turing, because a human is going to play the imitation game in a sense, right? So we'll see that in a minute. But the idea is to create a thought experiment where a very interesting little idea where a human instantiates a computer program, and then we could say definitely, well, I'm instantiating, I'm functioning like a computer, I'm acting my output is indistinguishable from someone who does have intentional states, and I don't have those intentional states. So he shows, that's what he thinks he's getting at, is he shows how a person instantiates a computer and can claim no intentional states here. So, okay, so 1 and 2, yeah, so the brain doesn't produce intentional states via a program. Because when the brain is in that program mode, there's no intentional states going on. And also, he thinks that a mechanism that produces intentional states must have brain-like causal powers. So it's a little bit stronger of a conclusion that, in other words, if there is a causal architecture that produces this, and only causal architectures can do this, then it's probably the case that the causal architecture that produces brain states that produces intentional states has to be a causal architecture that has quote unquote brain-like powers, right? So is that really controversial? All he's really saying is that if something's thinking, its physical architecture is probably going to resemble the brain. And, maybe he doesn't go into this, but, when we think about now, like, remember, this came out in 1980, but now when we talk about, primates and, the gorillas and that kind of stuff, whales, maybe dogs, pigs, we have, we have changed our minds a lot on animal cognition. So and even what we say, like not just animal cognition because we're animals, but like non-human animals, what's their cognitive states like? Do they have intentional states? They probably do. I think my dog does. So is her mental architecture similar to mine? Well, yeah, it is. The brains are quite similar in many ways. So there's similar kinds of architecture that go in. Searle would say, well, that's no big surprise. And then the critters in the world that we say maybe have sentience but no real cognitive or intentional states, their brains could be much, much different than ours, and the architecture is very, very little overlap. So think of it that way. That and maybe if we encountered Martians and we could chat with them, hopefully it's all peaceful, then maybe we might find out that their brains are produced maybe by kind of like evolution, and evolution occurred on a distant world and according to the same laws, and you basically get a similar type of architecture and you have intentional states over there. Sure, no problem. So, yes, remember, Searle is saying, yes, machines can think, and it's not possible to have intentional states unless only if there is some kind of physical architecture. So again, he's not saying, don't read this argument as saying, oh, hey, computers can't think, hence we have some kind of incorporeal or non-corporeal or soul, non-corporeal or immaterial soul that does the thinking. That's where thought is. No. He's just simply saying thought's not in your laptop. Forget it. And it's never going to be there as long as your laptop is simply a mechanism that's programmed. All right. So that's the basics of the paper. We'll look at now I want to look at the little experiment that really, this is the juicy part, is that the computer programs aren't going to produce intentional states. That's the interesting part, is the little thought experiment, quote unquote, the Chinese room thought experiment, that he thinks establishes this. But when you got it all established, he thinks all this flows out of it. So let's also look at it in terms of the term artificial intelligence. Now, Searle has no problems with artificial intelligence provided that you mean it in a certain way. So he divides it into two. Weak AI, strong AI. Those terms are with us today. There's various ways that people use those terms, but I think Searle's way of using it is fairly non-controversial. Weak AI tends to view AI in the sense of, in an instrumental sense, that the artificial intelligence can do a very specific thing. It's very narrow, kind of like when people say artificial intelligence is everywhere, it's in your phone. Does that mean there's a mind in your phone? Like, when you pick your phone up, is there a little mind in there? No, not really. Some people might want to push that line that it's stronger, but artificial intelligence in your phone just really means there's certain kinds of algorithms and programs in there that can do things, right? And for instance, autocorrect. You're typing things in and you have autocorrect on it, and then you press send, you realize that's not what you wanted to send. That is a simple kind of AI. That's a weak AI. It does a very specific thing, and it does it, very fast and does it well. So weak AI is all over the place. And Searle says, if you think about weak AI when it comes to the mind, that the computer is a useful tool. So that gets a smiley face, right? Yes, Searle thinks that's just fine. So is there artificial intelligence in the weak sense? Yeah. And he doesn't seem to have any problems with that. It's all over the place. That's pretty well undeniable when you really think of it. Artificial intelligence in that sense, is it here? Yup. It's, again, you're carrying it around in your pocket in your phone. The more interesting one, his target, is strong AI. And the strong one says that it's not the computer is a tool. The computer is a mind. And that's where he says, no, that's not right. Now remember, he doesn't mean compute, like don't confuse computer with mechanism or machine in general. Don't extrapolate and say, oh, Searle is saying that no computer, no matter its layout, could think. He's not saying that. He's just saying that computers in the standard way of viewing them as programmed machines, that are you going to write a program that's eventually going to start having intentional states or whatever, or maybe there's intentional states already in your machine. He says, no. Yes, colloquially, we often say, oh, my computer is not behaving well, or my computer is mad. I mean, my computer is mad at me. It won't listen to what I'm trying to get it to do. Sure, those are ways that we speak, but those are just, informal ways. It's not to say that your computer is actually angry, right? It's just not working the way you want it to work. You're the one who's angry. So in this sense of, as I said, I think he's channeling a lot of Turing in this article, as pretty well everyone has done after Turing when they talk about minds and brains and programs. And this one here, that to have this human instantiated computer, you can go back and look at Turing's 1950 paper on computing machinery and intelligence. He talks about a solipsism test, right? And that, some people would never accept that computers can think unless they could actually be a computer. Well, this is where Searle is trying to address this and saying, well, I've got an experiment where someone becomes a computer and they don't have intentional states. So computers, remember, in the sense of programmable ones, cannot produce intentional states. Okay, so there's the overview. There's your terrain. There's the big picture. There's the forest. Now let's dive into the trees by looking at the Chinese room thought experiment.